Hi, my name is Fred Park. I'm an associate professor here at Whittier College. I'm also the chair of the Department of Mathematics and Computer Science. And I'm here to talk about the mathematics major with you. So the math major here at Whittier College has a set of core courses that is required. And essentially what it consists of is the following, it's going to be Math 141 and 142, which is going to be Calculus 1 and 2. Math 241, which is vector calculus, Math 242, which is elementary linear algebra and differential equations. And then after those set of courses right there, we transition to upper division mathematics by way of Math 280, which is an abstract thinking course. So essentially, in that course, you'll learn proof writing. Math 345A is a differential equations course. And Math 380 is a linear algebra course. And then after you're done with those, then you have the option of either taking Math 440, which is an introduction to analysis, or Math 480, which is modern algebra. And they alternate each year. And the last component for the course, for the core in the major is Math 491, and that's senior seminar. Now, in addition to these core courses, students have to take at least 3 courses from the 300 level or above. And this brings us into the elective courses. And we have a broad range of elective courses. Some are going to be more applied, some will be more pure, and there are some standalone ones like history of mathematics as well. So if you take a look at these, you have some options like history of mathematics, number theory, probability statistics, advanced geometry, complex variables, numerical analysis, mathematical modeling, and point set topology. And one thing to consider is if you plan on going to a graduate program, you may have to take some additional courses. And so you want to work with a faculty advisor to ensure that you take courses that will be useful for a graduate program that you're interested in. Now, what's interesting about the math major is we have tracks in the major, and these will be a pure track, applied track, and a teaching track. And depending on the track that you take, these will adjust the elective courses that you'll take. And that one you'd consult with your advisor on which ones you would take depending on the track that you're interested in. Now, in addition to the mathematics major and the 3 tracks as mentioned earlier, we also have interdisciplinary majors, and these would be math business, math economics, and an integrated computer science math. And lastly, there's a minor in mathematics as well. And the minor mathematics, it requires a minimum of 20 credits. And so basically it'll be Calc 1 and 2, the transition to upper division course in Math 280 abstract thinking, introduction to linear algebra. And then you would have to take 6 credits of upper division mathematics as well. And these will be at the 300 level or higher. All right, so here's an interesting question is what are some projects that students will have completed by their senior year if they major in mathematics or any of the interdisciplinary mathematics majors? And here's a few that I have off the top of my head. And so some of these would be the following, like a predator-prey modeling of coyotes and rabbits on campus. So the interaction between those two. Another one would be predicting home prices from real estate data. That's an advanced regression topic. You could do predicting loan approval on consumer data, and that's using machine learning. And you could also look at an interesting computer vision problem of shape prior segmentation. And one of the most recent ones is clustering of COVID-19 lung scans. What are some of the careers that alumni of this major have pursued? Well, in addition to the recent graduates being accepted into top 20 or even top 10 graduate programs, many of our students have found employment at places like Google, Goldman Sachs, TikTok, and the Irvine Company, to name a few. So it seems like mathematics is quite useful, and there are lots of employment opportunities out there. So what is something you think students would find cool about this major? Well, the thing that I find that's really cool about the major is that you could work on real world problems, and you could even build an actual working product. That's something that's quite fun. Moreover, you have the opportunity of doing undergraduate research with the faculty advisor and even publishing this research. So I'm going to show you a case study that encompasses all of the aforementioned. And this is going to be an application of segmentation. So what's segmentation? Well, if you get an image, so if you get an image over here, for example, on the left, top left over here, you see a zebra. Well, we humans have high level vision, so we could automatically get the boundary of this particular zebra. But the segmentation problem is, how does the computer automatically do that? So the computer doesn't have the high level vision that humans do, but there is a way that it can actually get the boundaries of salient objects. So in this case, it can automatically detect the boundary of a zebra. It could, down here, it could automatically detect the boundary of what appears to be a leopard. Some might think it's a cheetah, but either way, regardless, you can get the boundary of that object. All right, so segmentation is a pretty simple one. Just give me the boundary of the object. That's all. Give me an image, give me the boundary of the object. Now, what's interesting is illusory contours. And these are contours that aren't really there. They're essentially an illusion. And our high level vision, due to an interpolation process, can view these and pick it up because we are quite good at pattern recognition. So for example, in the left side over here, we see an upside down triangle, even though the only real triangle there is this right side up one. The upside down one is an illusion. You could have a disk over here as well. So a disk, but that's not even really there. It's formed because of these emanating lines. A couple other ones. This one could be construed as a money sign, an S or an I. This one can be construed as 4 Pac-Mans, or the illusory contour, which is going to be the square. So that contour is actually not really there, but it's formed by the Pac-Mans. All right, so I worked with a student here at Whittier who's currently now at Google. And we worked on this illusory contour problem. And we came up with a method that automatically detects illusory contours when we can incorporate shape into a contour that evolves towards the boundary of the object. And this is what happens right here. This is the actual model being run, and we can detect this nice illusory contour. We could even do things like capturing the boundary of the Staples Center. So the Staples Center is obviously an object of interest right here, and we're able to automatically detect the boundary of it. And you can see that without shape information, you can't do so well. Our model incorporates that, and we can get the boundary almost exactly. We could also get the boundary of objects if they are occluded, so they're blocked, but we can still find the object's boundary, even though it's partially occluded in this case. So yeah, you can see the result right here from our method. Works quite well. And then the interesting thing about this is you could even publish your work. And so this work, the student worked on as an undergraduate and published it as an undergrad back in 2020. And so this is just one opportunity that many of the undergraduates in the math major have. Thank you for your attention and your interest in the mathematics major.